Francois. There we go.
Hey, Dennis, how are you doing? Are you rearing and ready for your first technical session?
Yeah, I've been looking forward.
I think, I don't know if it was my sound or yours. Okay, I think we're all good. Hello, everybody. Those of you already have joined us. Welcome to our technical training sessions, our Q&A sessions. We do officially start at 1 o'clock. So we do like to give a little bit of time for everyone to just log on to the call. We will have a formal part of the program where Dennis and I will just discuss some questions related to today's topic. There will be an opportunity for you to ask questions. So if you want to pop them in the chat, that's fine. If you do have a question and you'd like to ask it yourself, if you've got your camera on, I'm going to assume that you have a question to ask. If you don't have your camera on, I won't pick on you. So let's just, I'm going to be letting people in as we go along. So let's just give them all a chance to log in, and thanks for joining us.
Don Garcia, I see there. Are you the Don Garcia that used to work for Dorman Law? Don, you need to unmute your microphone.
Yes, I joined Dorman Long in 1965.
Okay.
It's a lifetime ago.
Well, so did I, except I was 67. And we met in Cape Town when they were building the transmission lines.
Yes, I was in Cape Town to do some drawings and stuff there too. I was sent from Joburg. I was in head office in Joburg.
That's right. Okay.
You want to see us?
Yeah, that's right. Yeah.
It was a weird one because they couldn't get these things to fit. And then they realized they were using timber templates. And every day in Cape Town, the timber stretches different sizes. So they had to make metal templates.
Okay. Oh, all right.
Yes.
So what are you doing with yourself now, Don? You're retired.
I'm working. No, I can't retire, man. Gee, you want to bury me, retire me.
Oh, okay.
No, I'm working still. I'm still working. I'm consulting now with a consulting engineering firm, yeah.
Okay, good.
Okay, fantastic. For those of you that are still joining us, welcome. I'm sure that more people are going to be joining as we go along. I'm Denise Sherman. I'm the Marketing Director at the Steel Institute. We've got Dennis, who's going to be running most of the session today, and then also Emmanuel, who's our Technical Director. If you've got any questions, just pop them in the chat. If you do have your camera on when we get to the question stage, I'm going to assume that you have a question you'd like to ask in person. So that's kind of how we're going to run it. I've got some questions I'll be asking Dennis. After that portion of our session, there will be opportunity for you to ask perhaps around the topic for today. And then maybe just if you've got any other questions, you can also ask them then. Okay.
Hi, Dennis. How are you?
Well, thanks, Emmanuel. Yourself?
Good, good.
As you can see, I've taken up temporary residence in your office.
Ah, cool. Someone's got to use it.
Yeah, one of my rare visits these days.
We have a good showing today. We have quite a number of people.
Yes, Denise tells me it's just on 70.
Cool. I know that my Zoom account can take 300, so I think you're good.
Oh, okay, good.
I think. I'm not sure. We'll see.
Oh, well, hopefully we don't have to test it.
Yes.
Hello,
Oh, hi. How are you?
I'm fine. How are you?
Good, good. Nice to see you.
I'm Rejoice.
Yes, Rejoice. Yes.
Thank you for the invitation.
No problem. Welcome.
Thank you.
Do we get CPD credits for this?
Not yet.
Not yet.
Not yet. But we are
EXA wanted, you know.
yeah, we're considering whether or not we should do it. We didn't want to put too much administrative cost on it because it's still free.
Absolutely, yeah. Puts adds cost to it, yeah.
Yes, yes. So, but we are considering different ways of maybe trying to get that somehow funded by someone.
Normally I give you something like 0.1 or 0.2
Yes.
credits, you know,
Yes.
something like that.
Afternoon,
Yeah,
guys.
I'll give you a 0.1 for an hour.
Something like that, yeah. Dennis, are you still working?
Yes, oh yes.
Sicey.
Yeah, I run the SANCRO, the
You-
South African Metal Cladding and Roofing Division.
Fantastic, fantastic.
Right.
Afternoon, guys.
Hello, everybody. Okay, so I think we're going to get going with our formal part of the program now. For those of you that joined in that didn't hear my introduction, I'm Denise. I am the marketing director. If I could just ask you, if you are not asking a question, just to make sure that your microphone is off. I am also going to assume that if your camera is on when we get to the questions portion of the program, that you have a question to ask. And I will pick on you. So if you don't want to be picked on, don't put your camera on. Okay, so Dennis, can you give us a little bit of introduction to SANCRO first of all? And what, Dennis, are you there? Dennis? Okay, well, while Dennis is getting his...
No, no.
Okay.
Sorry,
Your camera's off.
There we go.
You need to keep your camera on, sir. Okay, so tell us a little bit about SANCRO. What is SANCRO? Why do we need a SANCRO? For people who don't know what SANCRO is, give us the lowdown.
Okay, well, in a nutshell, SANCRO stands for the South African Metal Cladding and Roofing Association. And it was formed about 7 years ago and the intent is to involve all people in the metal cladding industry as a common forum and as a national body representing those parties. So we have members like producer mills, roofing profilers, roofing contractors, consultants, and people who supply allied products.
That's fantastic. Emmanuel, do you want to just give a quick hello and let people know what your role at the Steel Institute is?
Yes. So I am Emmanuel Gabriel-Meskel. I'm the technical director for the Institute, which basically means that I deal with all the various technical aspects of what the books that we publish, getting involved in standards development, and maybe related to this event is that I answer the technical questions that come in, or at least if I know how to answer them. If I don't, then I go to people like Dennis and others who are experts in their own fields of work, and we respond to queries. And so we had this discussion with Denise at some point, saying, well, we get so many interesting questions. Why don't we actually do like a weekly event to try to give people a little bit of a preview on the types of things that we get, types of questions that we get. And many of them do relate to roofing. And of course, for the first time, we've invited Dennis here to also participate. And I'm sure we'll continue to invite folks, right, Denise?
Absolutely, absolutely. Yeah. Okay, so Dennis, I'm going to share my screen. I've got a copy of your presentation over here. Do you maybe just want to get into what is the purpose of SANS 10400, of the series of standards, and just give us a little bit of an intro there.
Okay, well, as a background, there's three main pieces of legislation that influence the construction industry. The first one is the National Buildings Regulation and Building Standards Act, going right back to 1977. The other one is the Occupational Health and Safety Act, and then the Consumer Protection Act. And today we'll be looking at the compliance with the national building regulations, because you can comply with the national building regulations in 4 ways. 1, by rational design. 2, by rational assessment. 3, by Agrimore certification. And the 4th one is the deemed to satisfy or comply rules, and that's the whole of the SANS10400 series of standards. And the purpose of the national building regulations was to set out all the requirements to ensure that a building will be designed and built in such a way that persons may live and work in a healthy and safe environment. It's intended to reduce the number of regulations to a minimum and to replace municipal bylaws. But the one aspect of municipal or a sub bylaw is the conditions of title in suburbs. It doesn't supersede them. And then, of course, all technical aspects are to be covered by functional regulations. And now the national building regulations, sorry, excuse me, the 23 of them, all addressing different aspects of construction, and matched to those are the 23 parts or 22 parts of SANS10400, each linked in to one of the basic bylaws. But not bylaws, building regulations, sorry.
Okay, so Dennis, do the national building regulations apply to every new building?
They apply to every type of building. So that's from your garden wall to a carport to a chicken coop, to a house to an office block to a great big industrial building. But they only apply in municipal areas. They do not apply at this stage in rural and peri-urban areas and to certain government buildings. It is planned to change them when they review the national building regulations, but when the minister will get around to that, that's a secret. But yeah, that's where they apply.
Sorry, just a question here, Denise.
Yeah, go for it.
Yes, Dennis, do these apply in mining precincts?
Yeah, they do. They would apply to mining if it is within a municipal area. Otherwise not. Mining is separate by itself.
Okay, so let's get into the
So
meat.
a mine shaft, in all probability, would, and reduction works, a reduction works built in a municipal area would fall within the national building regulations.
Okay, great. Dennis, let's get into the meat of what we want to chat about today. What is new in SANS10400 Part B?
Okay, let's have a look at that. All right, Denise, if you would like to share your screen, there, Part B, those are the national building regulations pertaining to structural design. Very simple. I assume you're sharing with them. I can't see because I don't have a dual screen. Okay, so as you can see, there's only one set, B1, design requirements. That's all the requirements that are spelt out there. And then compliance with 10400B, as you see, is part of subclause 3 down at the bottom. What is interesting in the latest publication is in the foreword, they've added in a very sneaky clause, and it states compliance with this document cannot confer immunity from legal obligations. Quite what is intended by that, no one at the SABS can tell us that, but it's now been included in every one of the revised parts of the SAN10400 series. And if you have a look at it within the national building regulations, there are a number of standards, and there's 5 individual standards and 2 series of standards within that. Those are the only SABS standards, that are mandatory in terms of the national building regulations. However, if you work down into the building regulations and you get to the rules set out for the SANS10400 series, then you come up with another 46 standards that are intrinsic within the various sections or parts of the 10400 series, but we will address those because they mainly appear in the normative reference for the respective sections. And within SANS10400 Part B, there's been two standards added into the normative reference. The first one being SANS517, which is light steel frame buildings, and SANS1263 Part 1, safety and security glazing materials for buildings. The other additions being in the definitions, where there's a new one being added, which is 3.5 barriers, and it states that it's all walls, curtain walls, partitions, balustrades, and all glazing areas, whether permanent or temporary, intended to act as a barrier to prevent people from falling. That's the definition for barriers. There is a section we'll address a bit further on pertaining to barriers, and barriers have also now been included in the revised Part D, public safety.
Dennis, just give me a shout when you want me to progress to the next slide, okay?
Yeah, no, I'll tell you, another few minutes and we'll be there. If we go to Part 4, requirements, there's a new subclause 4.1c, and that's addresses the light steel frame building requirements. That's addressed there, and there's a whole section which we will discuss shortly. And then Figure 1, methods of demonstrating compliance with Regulation B1 has been deleted. Then Table 2, which is titled the structural response of buildings to repetitive actions and imposed loading, that's been changed, and we'll come to that in a minute. There's a new table part for the structural response of buildings, the same part, but where it comes into hail impact. How do you handle hail impact? That's been amended. It previously said if you could see a dent from 2 meters away, the material had to be replaced. It's now been changed to read, the test specimen shall be free from visible cracks or perforations. So you can have a dent as long as it hasn't got a crack or a hole in it, you're fine. And then, of course, there's a new Table 4, which applies to all the loading imposed on barriers. And Denise, if you go to the next one, there's Table 4. And points to note in the third bracket or box down is the soft body impact. That's completely new in this particular standard and has to be complied with, mainly pertaining to these glass balustrades, but it will also pertain to other balustrades, including handrailing.
So Dennis, just a question from my side, sorry to interrupt. What are the practical implications of the changes that have come in so far? I mean, what does it mean for the industry?
Well, there are a lot of requirements, as we'll get to a little bit further down in the notes here, as far as loading on barriers. Now, that's covered in part in SANS 10160 Part 2, the actual forces, but there are other aspects that have to be taken into account. And if you look at the notes going down underneath that table, it says the design of fixing should avoid reliance wholly on the pull-out strength of a single fixing. That's very important to note, that barriers cannot have a single fixing to a support post or of the balustrade itself or the barrier material to the supporting post. And it's also imperative that the fixing design takes into account the material into which the fixing is placed and the spacing between fixings. And that's the main emphasis here, is the cognizance of the loading and the types of fixings used. You also have to take into account the durability of those fixings if you consider in a sports stadium where you could have an anchor bolt rusting, etc. And then there's a complete new section in Annex B, which is entitled Impact Tests for Glass Walls, Partitions and Barriers, and it details the apparatus to be used, the test specimens, how they're to be prepared, and of course the procedure to carry out the testing. Right, does anyone have any questions at this stage?
Hello, Dennis. It's David Haynes here.
Oh, hi, Dave.
I hope you're well. I've switched on.
Yeah, very well, thank you. You're still in London.
Dennis, how all of these changes, it would appear there's a fair amount, there's a broad range of changes being made to the codes in very subtle areas. Has a lot of this depended upon experience gained in South Africa, but also overseas, like in the Euro codes and other areas of the world?
The whole section on barriers came out of international documentation and problems at sports stadia around the world where people have been involved in fatal accidents. And the National Regulator for Compulsory Specifications deemed it necessary to include some requirements specifically for barriers.
Okay, thanks.
Okay, so let's go on to what's new in Part L, which is titled Roofs. And this standard is effectively being totally rewritten from what was there before. Denise, if you go to your next slide, there's the regulations for Part L. And there you can see that the roof of any building shall be so designed and constructed that it safely sustains any actions, is adequately anchored against wind uplift, is durable, and does not allow penetration of rainwater to the interior, does not allow for the accumulation of water on the surface. As part of a roof and ceiling assembly, provide adequate height. That fits in with, I think it's part C or E there, where they give you minimum heights. And the other one, of course, is the fire resistance and combustibility. Now, that is very interesting, because if you go into the fire code, which is Part T, fire protection, cladding in itself doesn't have to have a fire rating unless it forms part of an escape route, holding area for people, or to prevent the spread of fire from one building to the other. Otherwise, cladding currently is exempt. And now if we have a look at 10400L, the deemed to satisfy requirements, in the forward, it's got that same clause about compliance with this document and conferring immunity from legal obligations. But under normative, there have been 20 new standards listed and one deleted. And amongst the standards listed is SANS10400, the lightweight steel framing, SANS542, concrete roof tiles, SANS959 Part 1, PV systems for use in individual homes, schools and clinics, standardized requirements, SANS1273, fasteners for roof and wall coverings in the form of sheeting, SANS1845, pre-finished sheet metal products for interior and exterior building applications. That's your color-coated cladding materials. SANS4998, which is continuous hot dip zinc-coated carbon steel sheet of structural quality, and SANS9634, which are continuously hot dipped aluminium zinc-coated sheet of commercial drawing and structural qualities. And those were included because of the vast quantity of materials that are being imported into the country that don't comply with standards from the structural point of view, and as well as the coating and the durability point of view of those codes. SANS10400 the waterproofing of buildings, has been added, and SANS10243 manufacture and erection of timber trusses. Now, that's one that's often overlooked and presents problems when it comes more to domestic buildings, but you do get small office blocks and that where this particular code would apply. And an interesting one is they've added in SANS10400XA, and this is a split personality of a standard, because there's part X, which is environmental sustainability, and part XA, energy usage in buildings. And that code is going to be used as the vehicle for going forward for all energy conservation buildings in South Africa. So it will be probably updated biannually, or at least once every 3 years. Unfortunately, it's been 7 years in the working and has yet to see the light of day being issued as for public comment. There's a lot of difficulty and matters to be addressed there, particularly pertaining to glazing and to fire protection and the insulating materials used. I think the Grenfell Towers episode spooked a lot of people. Mm-hmm. And then a very interesting one is SANS10400 Part 1, which is protection against lighting general principles. Sorry.
Just a minute there, Dennis. I see Emmanuel nodding his head. Emmanuel, was there a comment or a question that you wanted to just add in there? And while, just before you do that, Dennis, can I ask you to just tilt your laptop down a little bit so we can see your mouth? Because at the moment you look like Mr. Wilson from Home Improvement. There we go. Perfect.
Cool.
Okay, can you see me now?
Yes. No, I was just appreciating Dennis's challenge with trying to get documents published by SABS in let's call it timely manner, and just the general challenges that he was discussing. I was appreciating the problems that he's posing.
Okay, Dennis, the
right.
floor
Okay.
is yours.
If we carry on with Part L, under definitions, there's 7 new definitions and 3 reworded definitions. Now, the first of the new definitions is 3.4, and it refers to base metal thickness. Now, what's happening is that in a lot of countries outside of South Africa, when it comes to cladding or coated material, they talk about the base metal thickness, and that is the thickness of the steel core, and excluding any form of coating on it. And that, from a design point of view, often raises a few eyebrows when it comes to tolerances. And then added to that is definition 3.38, which is total coated thickness. And that's the nominal total coated thickness that would include applied metal coatings, but exclude organic coatings. And Denise, if you go on to your next slide, there's a little diagram there, which explains it. There's BMT is the steel core, which obviously gives you the strength of the profile once or contributes to the strength of the profile. Bearing in mind, cladding profiles, about 70 to 75% of the strength comes from the geometry. Then you've got your metallic coatings, which give you your TCT, and if you've got paint over the top of that, it would be extra. And this kind of makes things a bit difficult, because when you measure the product, you're always measuring the finished product, and you really don't know how much paint or how much metallic coatings there, unless you've got one of the fancy measuring devices, the magnetic measuring devices.
Sorry, a question for Dennis here.
Yeah.
So practically speaking, when I go and buy a roof sheet from the store, how do I know what the thickness is? I mean, a layperson like myself.
You have to, at the moment, you have to rely on the honesty of the vendor. And further along, we'll be coming to one of the requirements that's been added into L, and that is the branding of materials. So we'll discuss that in a few minutes. But otherwise, you just have to take, and of course, it's the tolerances. Which tolerances? If you look at our South African tolerances for thin gauge material, they match to the Australian tolerances, and they're pretty close. They normally 0.02 of a millimeter of the nominal thickness. But if you go internationally, some of the ISO, EN, and the Chinese standards allow much bigger tolerances. And what people do is that they say, okay, it's specified 5 for the roof cladding, but I can buy 4.8 and sell it as 5 because it's within the tolerance. And also you can get mills in Southeast Asia, which will give you, pardon me, a guaranteed yield from your coil. And again, the only way they can do that is to thin out the core of the material. So does that answer it for you?
Yes, but it's not a very happy answer, but yes. The answer is complete.
Yeah,
I'm just not. So for instance, if there is a tolerance issue, are those tolerances also stated in our standards, or do we have to go shopping for tolerances around the world to see if
no,
the vendors got it right?
That's why those standards that I mentioned earlier pertaining to color-coated material, hot dip galvanized, and hot dip zinc aluminium coatings, they all have tolerances in them, those coats.
Okay. Thanks.
So that's your one form of protection. The one weak link in that whole series is the SANS10400 for aluminium zinc. It's an adaptation of an ISO standard, and there's no cross-reference in that to the South African tolerances, but in fact to the ISO tolerances. So it's a vulnerable area, and at this stage, an application has been made to modify 9634 to take out the tolerances, the ISO references for tolerances, and include the South African references. And that code, pardon me, we will begin work on it in June to update that particular code.
And you also earlier mentioned the 3 different legal frameworks. If I am clever enough to figure out the thicknesses and it is out of tolerance, what is my recourse?
Well, first of all, normally, pardon me, let me just have a drink of water. What invariably shows it up is when the roof sheeting is trafficked, or you have exceptionally long lengths and they handle it and it kinks. But certainly at this stage, you're pretty vulnerable because with an aluminium zinc alloy, the tolerances as per ISO apply at the moment. The South African tolerances do not. That's the one weak link in the materials used for cladding. And of course, the other outside one is the pure zinc coating things, the titanium zinc like Rhine zinc. That's another one that has quite substantial thickness tolerances, but it's pretty rarely used, fortunately.
I see that John Barnard has his camera on and he's unmuted. So John, do you have a question for Dennis or a comment?
Yes, please. Thank you. I was just trying to find out how do I put up my hand to make a comment. But thank you, Denise, always sensitive and aware. Dennis, yeah, the one comment that I just wanted to add with regard to Emmanuel's question, I do know that ArcelorMittal does mark the galvanized steel sheet. They put a stencil definition 20 millimeters from the one edge. And it gives you the thickness of the material. It gives you the specification, or it should. You know, so there you would be able to tell.
John, if I interrupt you there,
Yeah.
Sorry,
Okay,
I don't want to cut you short, but that is discussed in a short while. It's a thing all on its own right, the branding, as I mentioned earlier.
Okay. Super. Thank you, John. Off you go, Dennis.
Okay, then getting back to the definitions, the one for the 312 combustible, the original version of 10400L said the opposite of non-combustible. They've now got around to defining what is combustible, and it's a material which is not classified as non-combustible when tested in accordance with SANS 10177 Part 5, Clause 8. So they've certainly addressed that. The other definition is 321, which is light gauge steel structures, and it's a steel structure consisting of cold-formed steel sections, which does tend to open it up to structures built from conventional lip channels and lip Zs, etc. Then another new definition is 332, a roof light, and that's a component incorporated into the roof assembly to permit the ingress of natural light. And a bit further on, we will discuss the two types of skylights or roof lights. Roof lights, the term we use, skylights, the American equivalent of it, because you get in plane and you get out of plane, but we'll discuss that in detail a bit further on. Right, then there's 335. You've got continuously supported metal cladding systems, and that's to comply with the, shall we say, the American way of building, where you have a timber substrate and you just put a metal skin over the top. And then 336 is self-supporting metal cladding, and there's a cladding system which spans between supporting members in its own right. Then under section 4, requirements, 4.1 general, that has been completely rewritten. So you would need to get up to date with that, because it's been changed quite substantially. And then 4.2, roof coverings and waterproofing systems. That's the heading of it. Clause 421 general. All reference to category 1 buildings has been removed. Now, for the benefit of people like David who are overseas, category 1 buildings are what used to be referred to as RDP housing. So that particular, there was a differential and there was a relaxation of some of the rules. That has now been taken away, and the rules apply to all buildings irrespective of their category. Then the other thing under general that's been changed, there were a lot of notes into the minimum thickness of material cladding, the coatings, whether you had to have an AZ 200, an AZ 150, a Z 275, whatever the case may be. There was also a requirement that if they were used in a coastal or highly polluted industrial area, they should be painted. Not that anyone paid any notice to that particular requirement. And the other note was that if you were supplying material that had an AZ or a Z200 coating, it had to be labeled not suitable for coastal and aggressive environments. That's been completely taken out. And there's a whole new section, clause 422, titled metal roof cladding and accessories. And in there, first of all, it addresses your continuously supported cladding. If you're wanting to use that, it has to be subject to a rational design. If you're using self-supporting cladding, which is the traditional metal cladding that we have in the country, it states that a self-supporting metal cladding system shall be in accordance with the requirements of SANS 10237, the design, testing, and installation of metal cladding. And that's a new standard that hopefully will come out for public comment during the course of next month. And then when it comes to metal thickness, it now states the minimum thickness for metal cladding shall be in accordance with the manufacturer's published span tables for the individual profiles, provided such tables comply fully with the requirements of SANS 10237. And in SANS 237, they require two types of span tables. One for gravity loads, which is a point and a UDL. And the second one is specifically for wind loads, because often cladding can span, for example, 1.8 meters, a particular profile in a certain thickness, could span 1.8 and carry all the imposed loading, but it certainly wouldn't carry the wind loading. So now it's not just a straightforward statement. The cladding is designed to handle 1.6 kPa or whatever the case may be. You have to give tables per profile, per span, and type of span, be it simply supported, end span, or continuous span. And in the absence of published span tables by the supplier or manufacturer, then you have to comply with the requirements of Table 1, and we'll be going to Table 1 right now. And then, of course, the other thing that's contained within that new 4.2.2 is that metal roof tiles shall comply with the requirements of SANS10400 B&L, which is a standard that's been around for some time and is also due to be reviewed within the course of this year. So, Denise, if you go to your next one, there's the table you have to use. If the manufacturer hasn't had tables developed that comply with the requirements of 10237. You get your corrugated, shows you your grade of steel, your minimum BMT, note that it's a base metal thickness, and then your maximum purlin spacings, double span. And then there's the note pertaining to wind uplift that's been added to that. And then if you go on to the next table, and that's the minimum thickness for uncoated metal. So in other words, this is your aluminiums and your stainless steels and copper, for example. And there you've got the minimum thicknesses that apply. And you will note that in the first note at the bottom there is that metal for roof tiles shall have a minimum base metal thickness of 0.36 millimeters.
Dennis, I see that Arno has his camera on. Arno, do you have a question that you'd like to ask?
Yeah, Dennis. Hi, Dennis. Arno here, BlueScope. If you can just go back to the previous table, just want to go through those again. So just to understand quick, on your 50 material, full hard, you've got a base metal thickness of 0.46.
Yeah.
So if you're going to do AZ100, that's going to give you 0.03 that you'll be adding. So your minimum TCT will be 0.51 if you do AZ100. If you do AZ150, you add 0.05, right? So you're going to be at 0.51 minimum TCT. And AZ200, you'll be adding 0.06. So with us supplying currently the market with 0.47, that will not be allowable anymore unless the roll former can show and have done their testing, correct?
Correct, yeah.
And then with your other profiles, are you referring to concealed fix that?
That's all other profiles. So that would be your box ribs as well as your conceal fix.
Okay. And is this purely for roofing? What is the cladding, side cladding?
Oh, that's interesting. The side cladding, the same rules, I guess, would apply. It's not, it hasn't been said.
Your
No, hang on a minute.
your
We're
wind
talking
load is not
roof.
applicable then.
No, hold on. Wind load definitely applies to side cladding.
Your wind uplift.
Because, you get suction on the corners of a building and at the back of a building. On the lee side of a building, the side cladding is subjected to a suction.
Yeah. So you would say your side cladding is going to have the same as this?
It would be, yeah. Whilst this talks specifically to roofs, it's silent on the point of view of side cladding, and nowhere in the national building regulations is the issue or the subject of side cladding specifically addressed.
Yeah, because
now,
currently majority of your specifications either call for 0.05 or 0.53 for that matter, and 0.55. Those are the
Yeah.
three for roofs. And then your side cladding, majority of the time, will be 0.47 TCT.
No, I don't agree with you. I think the bulk of side cladding is 0.5, and with some of the 0.47, yeah, could be accepted. Yeah, it depends on the specifiers and the manufacturers. Some guys manufacture galvanized product from 0.5 and aluminium zinc alloy product from 0.47.
David, was there something you wanted to add there?
Table 1 and Table 2, I take it these are deemed to satisfy rules where you're giving a maximum purlin spacing for a certain grade of material. Okay, it's a corrugated profile, so you know what that profile is, but all other profiles are not known. We don't know what those profiles are. So I take it these are very conservative, deemed to satisfy rules for a broad range of loads, or possibly the worst loads. Am I correct?
Yes, you're quite correct. You must understand this is setting the minimum requirements, and by definition, they're going to be conservative.
Okay, thanks.
Because they deem to satisfy, they're not subject to the rules of the design codes.
Okay, thanks.
Sorry, question, Dennis?
Yeah.
I'm just curious, the way this table is put together, you have the different grades somehow associated with thicknesses. Is that because that's prevalent in the market, or is there some other reason behind sort of this linking of grades and thicknesses?
Yeah, historically, before BlueScope Steel came to the country and we had ISCOR having a free reign, you had what was known as, commercial quality, full hard and full hard, and they didn't define it. Then that got changed once BlueScope came to the country, and they were talking about 550 MPa, and then ArcelorMittal introduced the ISQ standards. And yes, so for thin gauge, very thin gauge, high tensile material has always been used for cladding. Then in the sort of 0.58, 0.6 range, there was this sort of intermediate, which would have been your commercial quality, which is now your 300 MPa, a lot of it, but for cladding it's 275. And then your thick stuff, your 0.8 was always 230 MPa, the conventional commercial quality.
It's great to get lots of questions. Dennis, just so that you're aware of time, we've got about 15 minutes left. If you would just want to pace the rest of your slides that you have left, and then just open up for some questions as well.
Okay, fine. Then the other aspect or subject or title, whatever you want to call it, that's been added into metal cladding is section 4223, durability requirements. And it states the durability requirements for steel cladding shall be A, the minimum coating for steel cladding shall be as detailed in table 3. The minimum grade of aluminium or stainless steel shall be as detailed in table 4. All other metals shall be in accordance with the supplier's recommendations. And D, all zinc, aluminium zinc, or other metallic coated steel roof sheeting utilized within 1 kilometer of the coast, and it's in brackets high water mark, or in aggressive environment will be classified as classification C4 or C5. Now that's an ISO, it's ISO SANS have adopted the ISO code, and that's 933 and 924 standards of determining it, and we're coming to that now in a minute with the tables. And there, Denise, the next table will be table 3, and that gives you your minimum coating mass for the different corrosivity categories. And there it shows you how it's described in the ISO 9223, and then you've got your various coatings that you can use, minimum coatings. And then if you go to table 4, That's your categories for aluminium and the stainless steel. It's interesting that the tables in both cases, they refer to the CSIR classification ISO 9223. That, for some unknown reason, was changed because the original table stated it was SANS.
Not sure if it's just me, Denise, but
Yeah, I was just about to say, is that me lagging? Was that Dennis lagging?
no, that's Dennis.
Okay, I'll go and have a check on him now. Emmanuel, just while we wait for Dennis to come back there, what are some of the technical queries that you had come up recently?
Well, I'm very glad that Dennis is mentioning these things. I can sort of summarize the questions in a simple way to say, engineers, and myself included, have always been curious to know how we can figure out the capacity of these roofing and cladding systems when we go and specify them. Now, the traditional approach has always been, well, you go and ask the manufacturer. Now, the attempts that I've made to do so have always had curious responses. In some cases, there was really very scant information available. In other cases, there was diligent work done to establish the strength of these roofing and cladding systems. It was all over the place. So I was I'm very excited to see that Dennis and his group have actually managed to come up with some minimum requirements that we can rely on when we can't actually figure out properly evaluated capacities of roof and cladding sheets. So that's the main question that does seem to come up is, how do you know what the capacity is? Just because someone said so. All right, then how did that someone say so? Because this is obviously the job of an engineer is to find out if the methods that have been used to evaluate these things are in fact legitimate or not. And there's a huge gap in our market in that sense.
Okay, I'm going to try and see if I can get Dennis back into the room. David, do you have a question or a comment while I do some tech support?
To Emmanuel's question, yes, it was always a case of go to the manufacturer's catalogs and see what they offer, load span tables. However, and I refer back to some of the more popular ones, and I go back to the H.H. Robertson catalog of years ago. A lot of their load span tables were based on an applied load of 0.75 kPa, which represented a fairly high load, a high wind load, certainly bigger than the statutory imposed loads.
Yes.
And that was what their tables were based on. So if you were at the ragged edge with a wind load of 0.5 kPa or 0.6 kPa, you knew you had a little bit in hand.
Yes.
But there was no way of doing rational calculations without going back to all of that, to the basics and the profiles and all of that.
Yes, yeah. So we've been involved with some innovation projects relating to decking and roofing types materials, and you can't imagine how difficult it is to establish the capacity of these profiles when you actually get down and dirty in a lab, because of course the way these things behave is very much dependent on the boundary conditions, how it's supported, how it's attached, all these various types of stability problems that you get. So a hand calculation method is obviously out of the question, just because now I have experience with actually trying to test them in a lab and just seeing how difficult that was. So I've always been very curious to know how these things get rated, and whether or not they're actually legitimate or not. So this is actually good that we have these basic minimums now in the SANS standard.
Right, I think we should have Dennis back with us shortly. Just some of you have been asking about if we'll be making the presentation available or if Dennis will be sending through notes. We will do so after the session. I know that Dennis does usually like to do a nice bit of a technical wrap up in an article format, so that will also be available. Let me just see. Dennis, you
Oh,
are
sorry, Denise.
muted.
Yeah, the other question that keeps coming up, if I can interrupt.
Yeah, go for it.
Yes, is relating to how these roof sheets, whether or not they can brace purlins in the design of the purlin. So, in a way, this is a slightly different topic, but it is related.
Mm-hmm.
And there are several questions that come in relating to essentially the stability of the purlins and how that depends on the type of roof sheeting and connections and insulation and all that kind of stuff that is part of the specification. So that's the second type of question that comes up a lot relating to roofing, is how to design the purlins. And we try to cover that in our warehouse design type courses.
Okay, David, I see that you're unmuted and you still have your camera on.
That's something which is close to my heart, is the restraint of purlins by sheeting and or sheeting fixings. We have come across this over the years throughout my career. And of course, the current practice is to ignore the restraint on uplift, to not consider restraint of purlins by sheeting. And I think that's overly conservative. The reason being is that we just have not witnessed, and I'm sure there's many other engineers who would agree, not witnessed the kind of failures that would be implied by that conservative approach of taking no restraint by the sheeting on the purlins.
Yes, and I agree. And one question that I have asked also Dennis before is, so in the old days when you had the purlins directly attached to the purlins, there was maybe one approach. And now with the insulation, and especially insulation that presumably should not be crushed between the sheets and the purlin, what that means for the design of the purlin, and it's still an open area in a way, relating to what you were just saying, Dave, in terms of just new developments in essentially the requirement for thick insulation between the sheets and the purlins.
Okay, right, now we're back. All right, Emmanuel, to answer your question, that will form part of
we just lost. Yeah.
It's a highly complex thing, but from the point of 10400L, stressed skin design would be a rational design. There's no deem to satisfy for stressed skin. And then David's comments about the conservancy of accepting restraint of the purlins under uplift from wind load. There's a great deal of debate about that, whether it is a positive fixed as in an IBR or a corrugated sheet, or whether it's a concealed fix. A lot of people consider concealed fix in South Africa to be much the same, offering the same restraint as a positive fix. But internationally, if you look at some of these very lightweight steel Zs and channels, they say, no, you can't. But that will be a totally separate discussion outside of what we're discussing today.
Yeah.
And then, Arno, just to come back to you on your minimum BMT, that figure in table 1 of 0.46 was meant to accommodate your 0.47. So if we've got a problem there, you better drop me a note and we can see if we can get this thing amended.
Okay, Dennis, we've just got a comment from Don Garcia in the chat, which is stressed skin design utilizes the stiffness of the sheeting, but that is a completely different ballpark.
Yeah, which is what I've just said. It's a rational design and a whole new.
Yeah. So, Dennis, we've got about 5 minutes left, and I do just also want to make an opportunity for anyone who has any questions to just drop them in the chat. There's a significant, there's quite a bit of stuff that we do still have to get through in this presentation. So I want to just respect everyone's time. We do schedule these sessions from 1 to 2. So if you want to perhaps just, if you've got any questions, pop your camera on or put your questions in the chat. We will also be having another session next week. So if you don't get an opportunity to ask your question, you can always pose it in the chat or in next week's session. Any questions, any comments, any thoughts? I think everyone's all fine for now. Dennis, do Okay, so question
there's just
from...
a few more points that I want to highlight when it comes to corrosivity and the environment and choosing. With the last lot of tables we discussed, tables 3 and 4, there's a series of notes. And note 2 stresses the importance of considering both the macro and the micro environments. And a micro environment could be anything within a 5-kilometer radius of the site of the building, where you've got a foundry, you could be close to a motorway. We're picking up a lot of corrosion problems immediately south of some of the motorways, and I think it's the N21 that goes out through Boksburg to the east to Mpumalanga, and you've got the combination of air traffic and motor traffic, and we're finding it's proving to be an extremely corrosive environment. But there's some notes here about the fact that you have to consider the influences of the micro environment, which also includes activities within the building itself.
I see that Arno has his camera on, so I just want to make sure. Arno, do you have any other questions or comments?
Yeah,
there?
just quick, Dennis, just following up on and on John Barnard's comment as well on the branding on the sheeting.
Arno, I'm about to address that. Can you just hang on, please?
Okay, so you're busy. Okay,
Yeah.
I thought we were wrapping up.
Yeah, we were going to be wrapping up, Dennis. So let's not take too much more time, please.
All right. One of the critical things in this new code is clause 4224, marking requirements. And all the coil that is used to manufacture cladding in South Africa has to have the manufacturer's name, the base metal thickness, the grade of the base metal, weight of any metallic coating, and identification of any other type of coatings on there. And the marking is to be at not more than 3 meter intervals. And Denise, if you go to your next slide, there's some examples there of products in the most commonly used in South Africa, showing what the marking looks like. So that should answer John and Arno's questions.
At the slide with the brand name, width, galvanized coating thickness, etc.
Yeah. Okay. So there's typical examples of branding. If we look at the top one, which was an example from Chromadeck, gave you a TCT at this stage, but they're geared to do a BMT. The width of the coil is 925, because a lot of IBR people roll from 910, which doesn't give you the return on the lip, and you have roofs that leak rather badly on the side lap. Not to mention it also interferes with the span tables or spanning characteristics. There, in that instance, it's a Z200 coating. It's an ISQ 300, which is a 300 MPa steel, and then the rest is their references and dates, times, and etc. Then the middle one is the Blue Scope steel product, Zincalume, and there it tells you the quality of the steel, the total coated thickness, and who it's made by, and at the bottom is the Safel steel example of how they brand their material to comply with this new requirement. I think in the time we've got left, there's a whole section on fasteners, what constitutes a primary fastener, what constitutes a secondary fastener. And the big thing is that those horrible old drive nails that used to be bashed into timber are no longer acceptable as fasteners, either primary or secondary, on metal cladding in terms of 10400L. And then there's another whole new section, which is roof coverings in pitched roofs, that unfortunately we don't have time to go through a lot of the details there, but people need to go and read that. There's a minimum slope for sheeted roofs. That's table 5. That's your next example, Denise.
If anyone does need to drop off now, we are recording these sessions, and Dennis, if you perhaps need another 5 or 10 minutes, we can maybe do that. But if anyone does need to drop off now, thank you for joining us. If it's okay with everyone else that's still on call, we can maybe look at adding another 10 minutes, if that would be all right. Dennis, will you manage to get through the
Yeah,
rest in
we'll
10
get
minutes?
through it by then because we're just going to be looking at some tables.
Okay,
The
fantastic.
interesting thing is that in table 5, end laps have to be sealed. The previous edition of this table said if you had I think a 300 millimeter lap, it didn't have to be sealed, and if it was sealed, you could reduce it. No longer are unsealed end laps acceptable, and this is because of the problems with crevice corrosion and bimetal corrosion, etc. So unsealed end laps not permitted in metal roofing anymore. You will also notice that the minimum angle of the slope is also less than previously published. And then if you go to the next one, Denise, this is a whole new section that's been added in, and it pertains to thatched roofs, and the thatched roofs are linked to the climatic zones as defined in SANS 10400 XA. Now that's a bit of a problem because the current XA doesn't define that this well, and you have to go to SANS 204. So until the new XA comes out, this is a bit of a tricky area to be involved in. Then the next section is roof lights, and the notes there are roof lights shall comply with the requirements of SANS 10400 parts N, O, T, and XA. They then go into defining what is an in-plane roof light, and effectively an in-plane roof light, that is where the profile of the translucent material matches that of the cladding material, shall not be wider than a single translucent sheet width of cladding material. So whereas before you could have a continuous band in a big checkerboard pattern on a roof, that's no longer acceptable. You can only have a single width sheet at a time. And then the next thing is that the length of individual sheets shall not exceed 3.6 meters, and roof sheets shall be fixed over adjacent metal cladding, and roof lights shall have a minimum thickness or mass, depending on which material, polycarbonate 1.2, GRP or fiberglass as it's colloquially known, 1.8 kilograms per square meter. And then there's a maximum purlin spacing. There's a little table for that. Sorry, I didn't give you that one, Denise, but there is a table depending on the depth of the profile, what the purlin centers have to be. And there's also special requirements for the fasteners for translucent materials. And then an outer plane roof light is defined as roof light shall be installed in a manner that does not interfere with the structural integrity of the roof supporting structure. An outer plane roof light is where it's in the form of, for example, a small monitor or one of the standard designs of roof lights that are marketed. They must not rely on the cladding to meet the loading requirements. They, in their own rights, have to have it, or there must be some substructures underneath it. There's 4.3, waterproofing. It used to be called waterproofing of flat surfaces. It now refers to waterproofing to balconies, terraces, and parking decks, and there's a whole lot of descriptions there and requirements to be met. And then under section 4.4, timber roof construction, this is a completely new section from what was there before. And there's additions have been a section on the support for geysers and installation of solar geysers of less than 250 liters. There are requirements for the installation of solar geysers in thatch roofs. Then there's a section for pole construction, including fire regulations for that particular type of construction when associated with thatch. And there's a whole section about light steel construction. And then the next table you've got, Denise, should be table 21. And this is easy to use for traditional coal-formed lip channels when it comes to branding, stroke purlins, and rafters.
I only have up to table 17.
Have you got table 17?
Yes.
Yeah, no, that's it. That's the table I'm talking about.
Okay.
And then finally, if we have a look at the annexures, the original 2 editions of the standard only had annexure A, which has now been expanded. And the principles of waterproofing details that were given, there was a whole series of sketches, have been considerably expanded to meet the modern penetrations through roofs and items installed on roofs, etc. Then there's an annexure B, which is completely new, and that provides standard flashing details for metal cladding. And please note it's a normative reference. Annexure C is the standard flashing details for concrete tiles, and annexure D is the series of tables pertaining to the compatibility of metals and metal coatings. In other words, your bimetal corrosion, etc. And that's it. Thanks very much for staying on for the extra time. I don't know if there's any more questions.
There is one in the text where Francois is asking when you think Part L will be released.
Part L's been published. It was published in January.
Okay. And just a second one from me, which is that deemed to satisfy requirement minimum slope of 7.5 degrees seems quite steep.
Don't forget that's for pierce fixed and that's for corrugated iron. You can. It depends on your length. I mean, you can take corrugated iron down to 3-4 degrees if you really wanted to, as long as your length was only about 5 meters, 5-6 meters. The biggest problem you've got is that people don't seal the side laps, and when you get fine hail packed on the roof leaks like a sieve. So those tables again are conservative, and hence the steep. By modern standards. Yeah, but if you look at the requirements that will be in 10237 for IVR and other box profiles, there's a limit there. I think it's 5 degrees, if I remember correctly. And your conceal fix are limited to a minimum slope of 2.5 degrees. And you will also have to take into account deflection if it's a timber structure.
Yeah. Thanks, Dennis. Thanks. That was very good. Thank you, Dennis. I think we might have to organize yet another session with Dennis, seeing how we've run out of time. In a few months.
Yes. So we have got our next session that's coming up that Dennis will be presenting is on the 26th of May. That's relating to hail guard specifically. Next week, Emmanuel will be speaking about bolting and welding, I believe, is the question that's next on our list. So if you have any technical questions related to whether it's cladding or structural, you can pop them through to technical@saisc.co.za, and then Emmanuel will address them in our next session. Or if during the sessions you have a question, you can always pop it in the message section, or if you're brave, put your camera on and chat. So these sessions do happen. Emmanuel's sessions are every 2 weeks, and the in-between weeks, for the next 4 weeks, Dennis will be presenting something that's specifically related to roofing and cladding. And then in future sessions, some of the other directors from our other associations, perhaps even SASFA or the ASTPM, will be speaking about their areas. So thank you so much for joining us. Thank you for bearing us with us for the extra 10 minutes.
Denise, if I may just have 1 minute.
Yes, Dennis.
Included in their questions, if there's specific subjects on roofing that they would like us to address in the future, they can please send those in as well.
Super. Thank you so much, everybody. The recording of the session will be available on our YouTube page, and I'm pretty sure that Dennis has got a technical article brewing that will be covering some of this information. So thank you so much, and thanks for joining us.
Thanks, Denise.
Thanks, guys.
Ciao.
Thanks, everyone.
Thank you.